Hello students, good afternoon to all of you.
Good afternoon, ma'am.
Good afternoon, madam.
We were discussing application of number theory yesterday, right? If you have any specific doubt before this, chapter 1, 2 and 3, can ask me. Anyone having any doubt before this?
Ma'am, RSA.
Anything else? No? Anyone else having any doubt? No? Okay. So let me revise from here only. RSA will be included in this. Okay.
Okay, ma'am.
So yesterday we discussed about the GCD, right? And there are many ways to find GCD. One is by prime factorization, another is by Euclidean algorithm, that is log division, a long division method, right?
Yes, ma'am.
So every the GCD of A and B you can write as linear combination of A and B. And what do I mean by that linear combination? You can find some integers S and T such that you can write S into A plus T into B. Okay. Like here, the city of 252 and 198 is 18. So you can find some numbers. Is that 252 into 4 and 198 into minus 5. Okay, this is equal to 18. Okay,
Yes, ma'am.
hence 18 is the linear combination of 252 and 198. Then we have done this one, that is if in general division is not possible, that is if you have A into C is congruent to B into C. From here you cannot always write A is congruent to B mod M. Okay, B mod M. You cannot always write this. Okay, here to here you can write, that is if you have A is congruent to B mod M, you can multiply by C, but division is not possible. One division is possible if this dividing factor, that is divisor C, is coprime with M modulo. Okay, if C is having GCD with M as 1, only then you can write this one. So this is exception in case of division. Division property not always holds. Okay, clear?
Yes, ma'am.
So we did the proof. Then we did this inverse. That is, if A and B are relatively prime, then you can find the inverse. In fact, this inverse will be unique in modulo M. Okay, that means every two inverse, whatever you find, that those are uh, congruent. Okay, under modulo M. Clear? So if just check whether A and M are having GCD1 or not. If yes, you will be always able to find the inverse. Okay. Then with this question, that is how to define the inverse. A is the
Ma'am,
integer, just that it is having GCD with M is 1. Okay. Then it will satisfy the inverse equation. That is what is that? Inverse congruence. X is the inverse of
AX.
the integer.
AX.
I'm again just emphasizing on this integer part because x will be always integer in modulo n. Okay, the integer x will be inverse of a and x will be inverse of x. A will be inverse of x. If you divide a into x by mod m, that is by m, you are getting 1 as remainder. Okay, this is congruent to 1. You can solve it. One way is m divides ax minus 1, right? Find the value, one value of x. If inverse exists, if this GCD of A and M is 1, then surely there will be one X that is present from, that is lying between 0 to M.
0 to M.
Okay. Okay. And for suppose R you find, and for other inverses you can add multiples of M. Okay. Another way is you just write AX plus MY, that is linear combination. One is the GCD of A and M, so one you can write as linear combination of A and M. Okay, so here apply mod M on both sides. So AX is congruent to 1 modulo M. Okay, here it is 0, right? So this is the that X will work as inverse, whatever you find in the linear combination part. Okay. So if you are done with inverse, you can easily find the linear congruence solution for linear congruence. Linear congruence is of type AX is congruent to B mod M. Okay, AX is congruent to B mod M. So one way is just by definition of congruence modulo M, that is M divides AX minus B. Okay, find one value. If A is coprime with M, so obviously then its solution will exist. Okay, and from 0 to M, one solution will always exist if A is coprime with M. Okay, so here you will find some R solution. Okay, for other solution you can add MK. Okay, another way is you just multiply A inverse on both sides. So if you multiply A into A inverse, this will give you 1. 1 into X, it will give you X. X is congruent to B into, suppose B is the inverse of A or C is the inverse of A, then it will be B into C mod M. Okay, now you can reduce this one under modulo M, and for other solutions you can add MK. Clear? Then we did this Chinese remainder theorem, that is if MIs or MIs, MK, these are pairwise relatively prime. Okay, then with this congruent system, then there exists simultaneous solution which will be unique. Okay, unique solution exists and under modulo M, and M is the product of all these MKs. Okay.
Yes,
Yes, ma'am.
And the solution will be you will find you have MKs, right? You have M. You will find MK, capital MK will be M product of MKs divided by MK. Okay, small MK. So as these all MIs and MJs are pairwise relatively prime, means having GCD1, and in this product, out of this product we have divided by this product, we have divided by MK. So MK is not present in capital MK. So capital MK and MK, as here every MI is present except MK. That's why it will be having GCD 1. So capital MK with small mk, GCD of this these two will be 1. So inverse exists. So suppose inverse you find as yk. Okay, for m1 y1, for m2 y2. This will be congruent to 1 modulo mk. Okay, under small mk. Then multiply these ai's, that is ak for kth. So it will be AK, MK, YK. This is congruent to AK mod MK. Okay, AK mod MK. So this is the solution. If you replace this X with this one, this is the solution corresponding to Kth. Okay, so if you just multiply this one, so let me show you. Yeah, this will be the solution for AK, that is Kth. Okay, this will be congruent to AK mod MK, and if you replace X with this one, but this is not solution for others. For others, you need to add all these. That X will work for all, and you can also reduce under mod M, and M is what? Product. Okay. Then you have this Fermat's-Little theorem. If you have P is prime and A is integer which is not divisible by P, then we can have, if you are asked some integer raised to power P minus 1 under modulo P. what it will be. You can directly check whether this is prime or not, and A is divisible by P or not. If not divisible by P, and also check whether this power is P minus 1. Then you can, without any calculation, you can directly write this will be 1. Remainder is, that is A raised to power P minus 1. When divided by P, this will give you 1. Okay. In general, A raised to power P, when divided by P, this gives giving you A. Just multiply A on both sides, you are getting this one. Okay. Then we did pseudo prime number. If n is composite number, okay, then and satisfy this type, this Fermat's little theorem type statement. That is, b raised to power n minus 1. Here it was b minus 1, so it is n minus 1 is congruent to 1 modulo n. So under this composite number, if it satisfies this one, then n is a pseudo prime, and is called as pseudo prime with respect to base this b, whatever its power it is coming as 1. Okay. And if it is happening, n is composite integer, okay, composite number, and if this congruence is satisfied, b raised to power n minus 1 is congruent to 1 modulo n for all positive integers p with GCD b comma n 1. Okay. If you collect all the bases, all the positive integers such that which are having GCD with n is 1, and this n satisfying this condition with b. Okay, then this n is known as Carmichael number. We proved this one by using Fermat's theorem and so on. Then we did this one. Yeah.
Ma'am, example of Fermat's little theorem is there?
Where?
Ma'am, any example so that it will be easy.
Okay. So in modulo 5, if I ask you what is the value of this one, then you'll go for modular exponentiation, right? Right? B raised to power n mod m. Okay, we need this one. So, but I can directly give you the answer that it will be 1. Why is it so? P is prime. I have just checked that P is prime, right? And this number is not divisible by P, right? Not divisible by 5. And this number is P minus 1. So, the necessary condition for Fermat's little theorem is P should be prime and A is not divisible by P. So, then we can have A raised to power P minus 1 modulo P, we can directly write as 1. Clear? So, this type of questions may be there.
Okay, ma'am. We have in MCQ, we have to select the answer like this.
Yeah. It will be 1, 2, 5, 7. They will just give you, right?
Okay, ma'am.
I have not seen the paper, so I don't know what they have. But like this MCQ can be there. Okay. Just writing GCD as linear combination of A and P. Inverse, if this is given and this is given, then showing that this is the inverse of this one under modulo this one. That means you need to just multiply both and divide by 2436. Are you getting 1? That is 937 multiplied by 13. Is this congruent to 1 modulo 2436 or not? 2436 or not? If yes, then it is the inverse, and this is the inverse of this one, right? Find the inverse of 2 modulo n. So just you can, by using Euclidean algorithm, you can find, that is writing 2 is coprime with 17. So just write the linear combination and then apply modulo 17. You'll get the inverse. Or solve this. 2x is congruent to 1 mod 17. Okay. So 17 divides 2x minus 1. Okay. Find the value of x. For other values, you can just add 17k. Okay. Same here. Modulo 17 we are working. 2x is congruent to 7 mod m. So here, directly if you want to find 17 divides 2x minus 7, one way. Another way is find this x. Another way is just multiply the inverse of 2 on both sides. Inverse of 2 we got from here, right? So
Yes, ma'am.
x will be x into 2 into inverse of 2. That will be giving you 1 into x. That is congruent to inverse of 7. Inverse of 2 we
7
got as
into inverse of 2.
7 into inverse of
Inverse of 2
this
modulo
one.
7.
So inverse of 2 we got 12, or you can just 12 or what? 9 will work, no? 9. In positive it is 9. If you want negative, it is -8. Okay. You can also multiply with -8, doesn't matter, because -8 and 9 are congruent in modulo 17. Okay. So 9 is also working for this one. 2 into 9, 18 minus 1. 17 is divisible by 17, right? So x is also working as 9. For other inverses, you can add 17k. So 9 into 2, that is giving you 1 into x, that is x is congruent to 7 into 9 modulo 17. So this is 63 modulo 17. So what is that? If you want to reduce that, what is the answer?
12.
12, right? 63, that is 17 3 are 51. So 12 will be answered. For other solutions, you can add 17k. Okay.
Yes, ma'am.
In Carmichael number. Yes, this B you select because if we want to show for all B. So you select in general. Okay. Any specific doubt in this one? We have encryption and decryption. Here key is given N and E, right? N is modulo N, modulus, and E is the exponent. And we're taking power, right? So N, how it is given? N is equal to P into Q. P and Q are large primes. Okay? For example, 200 digits, 300 digits, and so on. And E is given, E is the integer given that is relatively prime to P minus 1 into Q minus 1. Okay? It is relatively prime to P minus 1 into Q minus 1, this product. Okay? It may not be relatively prime with this P into Q, but it is surely given as P minus 1 into Q minus 1. Okay? For RSA encryption, what you do to encrypt the message with this key, you translate the plain text message, whatever text message there, into sequence of integers. Okay, integer part. How? A is getting replaced with 0, 0. B is getting replaced with 0, 1. C is getting replaced with 0, 2. Okay. Then what you do? You just take 4 digits. Okay. Take the blocks of 4 digits, or you can just say equally sized block, you can just say of 2 in order. Okay. Then
Yes, ma'am.
what you do, for example, stock, in case of stock, what you do, you got 14, 15, I think, or what? This is 14, 15, this is 18, 19, right? S is getting replaced with 18, 19. This the integer transformation for this text is 18, 19, 14, 15. Okay. Then what you do? You take the block of 4 digits in this case. When you have 3 digits, you can take the block of 2 digits. Okay, that is 3 letters. In 3 letters, you will be having that is 6 digits will be there. So 2 to 2, you can take it. Okay. So here you got as this one. Take this as M1, this as M2, M2 block, first block, second block. Then M1 raised to power E. Modulo N. N will be given, here it is given as 2537. E is given as 13. Okay. For M2, it will be M2 raised to power E modulo N. Okay. Clear? So whatever
Yes,
it is coming, suppose first is coming as C1, second is coming as that is M2 raised to power E modulo N. If it is coming as C2, then write C1 here, C2 here. That will be your encrypted message. Okay. Corresponding to M1, you have C1. Corresponding to M2, you will be having C2. Clear?
Yes, ma'am.
Yeah. Then you have decryption. For example, in this one only, encryption, E is given as 13, N is given as 43 into 59, that is coming to 537. Okay, where P and Q 43 and 59. So stop is getting converted. The numerical equivalent is 1819, and with two blocks you can group it, right? 14, 15. Then for encryption, use the key this raised to power 13 modulo 2537. By using modular exponentiation, you get these digits at this first one is getting replaced with 2081, second one is getting replaced with 2182. So this will be your key. Okay. It's your encrypted message. Now you want to decrypt this. Means to say you are given this one with N and E. Okay, with P, Q, and E. So what do you do? First take the this C1 and C2. This is given. In general, if it is C, so you take inverse of E, C raised to power inverse of E, that is D mod M. Apply mod M. Whatever it is, it will come, that is congruent to 1 M. Okay, and how this D is, D and E, D is the inverse of E modulo, is the inverse of E modulo E minus 1 into Q minus 1. Understood? So first find the D, that is inverse of E, under modulo this one. D is given, Q is given, so you can get the product of this one. And then take the power D for this one, that is C1 raised to power D, that is 2081 raised to power D. Actually, D is the inverse of E, and inverse of 13 under modulo P minus 1 into Q minus 1. So P minus 1 into Q minus 1 will be 2436, and we have shown that we have calculated this in the last exercise that 937 is the inverse of 13 under modulo this one. So 937 will work as D. Okay, D is 937. Then you can take the 937 power of this one, that is B raised to power n mod M, that by taking modular exponentiation for this one. Now you take this 2537, okay, mod M. This will be equivalent to 1819 that you can calculate. Next will be equivalent to 1450, and then this is S and T, that is O and P, right? Second block will give you O and P. So in case of decryption, you do the, what do? You apply inverse. And inverse, why inverse under modulo this one exists? Because E is given, is coprime with this, is given as coprime, having GCD1 with this product. That's why we are sure that inverse exists. And you try to find this one, then translate into English letters, you get it. Any other doubt? Any other doubt?
No, ma'am.
Then we discuss about matrices. Definition done. How to show equivalent two matrices equal, that is corresponding entries are equal, right? And obviously the order is same. Then we discuss about sum. For sum to be compatible with addition, that is, should be the order should be same, right? Subtraction and addition both are done, right? A plus B will be Aij, that is ij entries for both matrices. Sum. Subtraction will be subtraction of this one. Then product we discuss, that is product of A and B. Here, for product to be compatible, there are number of columns for A, that is K, and number of rows for B, that should be same. And then AB will be having order M into N. Okay, so its ijth entry is Cij. This is getting how it is done. Ith row from here and jth column in B matrices. First entry is getting multiplied with first one, that is AI1 is getting multiplied with B1J. AI1 getting multiplied with B1J plus AI2 getting multiplied with B2J and so on up to AIK is getting multiplied with AKJ. Clear?
Yes, ma'am.
Then we defined 0, 1 matrix, that is special type of matrix, that is having either 0 entries or either 0 or 1 or both, right? Then we defined some based on the 0, 1 matrices only. Based on 0, 1 matrices only, we defined the Boolean operations, that is one is join, another is meet. Okay, join is like disjunction of ijth entry with from A matrix with ijth entry from B matrix. Okay, and how it is done? 0 you can take it as false, 1 is you can take it as true. So disjunction will be false if both are false, means this will be 0 if both are 0, otherwise it will be 1. And meet is the conjunction of corresponding entries. That is, if you take 1, 1, 1 and 1 both, then it gives you 1, otherwise 0, right? And these are also denoted by this one. This is your meet of A and B conjunction part, and join is represented by disjunction of A and B. Okay. Then we did this matrix multiplication, that is Boolean product of A with B. So same, the order will be same here. Also, number of columns for first matrix should be equal to number of rows for second matrix. Okay. So if Aij and Bij is the matrix, then Boolean product is represented by dot with circle. This will be having what order? M and N. Everything else is same except this notation and operations. Okay, with the normal product. In the normal product case, A dot with B, right? And this product rule, that is necessary condition for product, it is same, right? That is number of rows for A should be equal to number of columns for B. Then Cij, that is ijth entry from here, it is given by this one, that is earlier it was AI1 multiplied with B1J, AI2 plus AI2 multiplied with B2J plus and so on AIK multiplied with BKJ. Here you just replace this multiplication with meet and addition with
Join.
You will be getting ijth entry from Boolean product of A and B. Okay.
Yes, ma'am.
Join and meet. Join will be distinction of 1 and 1, that is 1 and 0, and so on. Meet, don't try to multiply it. Here just I give you analogous part, okay? Make you remember. But here it is operated, right? Operation will be used. Okay. those disjunction and conjunction. In case of meet, it will be conjunction. In case of meet, there will be one only, right? Everything else is 0, right? At this one, 0, 0, 0, 0, 0, right? And at this junction, this will be your 0, everything else will be 1. Clear?
Yes, ma'am.
Then we discuss about the Boolean product of A and B. So here the number of rows, that is 3, and number of columns here also 3 equal. It is 3 by 2, and this is your 2 by
2 by 3
okay. So here number of columns should be equal to number of rows.
rows.
Okay. So in the Boolean product, how many rows and column will be there? 3 by 3
into 3. Yes, ma'am.
So the same way this is getting operated with this one. That means first one, there we used to multiply, here it is meet. So first one conjunction with first one conjunction 1, right? Disjunction 0 with 0, right? Conjunction of 0 with 0. Then next, okay, for this one 1 1, right? Conjunction of 1 1. Disjunction conjunction of 0 1. Next, conjunction of 1 0, conjunction of disjunction with 0 1, right? That is this one. Like this,
Yes,
you can calculate all this matrix. You will be and end up getting 0 1 matrix only. So product will be always a 0 1 matrix. Okay. If A is a square matrix, that is M is equal to N, right? Number of rows and columns are same. For that, you can find the Rth power of A. Okay? Rth power of A. That means in the same way as we try to find A raised to power R, that is R times A multiplied. A dot A dot A and so on for up to R. Okay. In case of Boolean product, this is getting bracket. This is getting bracket. This will be equal to R times Boolean product of A, right? This is Rth Boolean product of A. Okay. So first find A square, second Boolean product, then A square multiplied with A, third, and so on. Okay. Here you have A raised to power N. For all positive integer N. A is given. So for all positive integer this one N, you will always have 0 1 matrix. Okay. All the powers will be 0 1 matrix. So A square you get A product with A. A cube will be A square Boolean product with A. You're getting this one. Then A cube, A raised to power 4. A raised to power 4 is A cube with A. Okay. Then A raised to power 5, you got A raised to power 5, 4 into A, that is Boolean product. So at this 5, you got all entries are 1 1 1 1. Okay. And if you calculate A6, again you are getting all entries as 1 1 1 1. So whenever it start repeating, you stop there and just write. So for AN, for n greater than equal to 6, it is equal to A5. Okay. Again you are just having 1 1 1 1 1 1 1 1. Okay. Then we did this one, finding this matrix if product is given as third one. So just take inverse of this on both sides, multiply. This multiplied with inverse, this will give you identity. Identity into A will give you A. Okay. and the inverse of this one. If you are applying inverse on left hand side, just multiply on left hand side, and if you are applying on right hand side, some matrices, then it will be multiplied on right hand side of this matrix. Okay, find the inverse of this matrix by using you can I'll use this adjoint of A divided by determinant of A. That will be your A inverse. So with the help of that, you can find the inverse. You got this one, and then you got this matrix A. That will be the product of these two. Okay. In this one, you need to show that this matrix is the inverse of this matrix. So again, there are two ways. If this is A, this is B. So first, what you do? One way, the simplest one, just multiply it. Are you getting IN? Okay. In this case, I3. So that is identity of order 3. Just multiply it. Are you getting it? Yes, you will get it. This means this is the inverse of this one and this is the inverse of this one. Okay. And another way is take this matrix and find the inverse of this one by using adjoint and determinant. Okay, that is standard cofactor and that is determinant method. Okay. Any doubt?
No, ma'am.
Then we did this one, find the Boolean product of A and B, where A is, how many columns are there? 3 into 4.
4.
This should be 4 into
4 into 3.
2 or
2,
3.
2, 2, 2.
So here it is, same. So the matrix, the Boolean product of A and B will be 3
3 cross 2.
cross 2. Clear?
Yes, ma'am.
Getting this one. So here the chapter 3 completes. If you have any specific doubt from chapter 1, 2 and 3, you can tell me. We have 20 minutes left. Yes? No doubt? Any doubt from induction and recursion, mathematical induction, PMI? We're just trying to show, verify it, first element of the set, right? Inductive step is assume Pk is true. Then Pk plus 1. Okay. Then strong induction. By using strong induction, what you do? In case of mathematical induction, first principle, you assume only Pk. But in strong induction, what do you assume? Up to Pk. Okay. Suppose it starts with P1. Okay. Then P1 is true, P2 is true, and P3 is true, and so on. Pk is true. Then it is Pk plus 1. Or Pk plus 1. So strong induction is very, very useful. So because you can use any of these between them, okay, to prove Pk plus 1. And we use that. Here your Pn is this one. And the element starts with 2, that is set with starts with 2, right? For this one, what is Pn? N is greater than equal to 2. You can write every amount of this this number greater than equal to this one, that is N. You can write as, you can form N by using 4 cent and 5 cent. So 4x plus 5y. X and y are non-negative, greater than equal to 0. So you need to prove this one. For P12, you assume it, verify it, then you assume 12 to K. Then prove for K plus 1 by using strong. And by using induction only, you can just assume Pk. Okay. Then this one, determine whether amount of postage can be formed by using which amount, that we need to Check it. So 4 cent stamp and 11 cents. So 4x plus 11y. This is n. N can be formed by using 4 and 11. Okay. So this n is greater than or equal to which number we needed to find. So what start with 4 and up to 28 you don't get any 4 consecutive number. Okay. Starting from 30, 31, 32, 33. We got 4 consecutive number. If we are able to write all four consecutive number, that is minimum of this one or this one, then we are able to write n is greater than or equal to this number where it starts. Okay. For 30 you can write, for 31, 32, 33. Okay. Then assume verify for P30, assume for P30, P31 and so on up to PK, prove for PK plus 1 by using strong. And mathematical induction, the first principle, this will be PK only assume, okay, P30 verify, PK assume, and then go for K plus 1. Then we did this recursive definition, that is specify the value of function at the first element of the set. If it is non-negative, then it is specify at 0. Recursive step is value of function at larger integers you can get from the value of function at smaller integer. That is recursively you are able to find function from the function output. That is your recursive definition. So in this one we had two types of formulas, two types of recursive or inductive you can just say. So two type of problems. One is recursive definition is given, you need to find fn or f at some value. Okay, like this. Recursive definition is given, you want to find fn, right? That is explicit formula for fn, what it will be. And in sometimes fn will be given and you need to find the inductive definition, that is here two steps now, basic and recursive or inductive step. In somewhere you need verification also. Verification means you are able to find all the values of f. Okay, we did this one, factorial from factorial to recursive, summation to recursive definition. Then from recursive definition to finding the sum values, so it will be n minus 1. Then we do this one, determine whether each of its proposed definition is valid recursive definition or not, from set of non-negative integer to set of integer. That means starting from 0 to infinity, if you are able to find the image of every element, then it is valid. Then you can give the formula, otherwise not. The first one is not valid because f1, f0 it is okay, 0 is going to 0, f1, 1 is going to 2 of f 0 minus 2, 1 minus 2, that is f of 1. So 2 of f of minus 1 actually. And f is not defined as negative integer. Okay, its domain is non-negative. That's why it is not defined. So for all odd numbers, it is not defined. At even you can find, right? So this is not a valid recursive definition. That's why this is not a valid recursive definition. That's why we can't write explicit formula for fn. And for this one, we are able to write this one, and this one. For second one, it was 1 minus n. For third one, it is 4 minus n for n is greater than or equal to 1, and for 0, it is 2. And for this part D, you're getting when n is even, 2 raised to power n by 2. When n is odd, n even. When n is odd, n by 2 plus n plus 1 by 2. Okay? N is odd. This is the formula. Or in general, it will be the floor function of n plus 1 by 2. Okay? Then we discuss this last part, 3 raised to power, and it will be coming as, if you open it, it's coming as 3 powers, 3, 9, 27. So it will be 3 raised to power n. Okay? Recursive definition of sequence will be This one, that is, you need to give the recursive definition for the given sequence. So fn, an, anything you can represent it. It is given as the explicit formula. From explicit formula, you need to give the recursive definition. That is the opposite of this one. This is where first term you will define n is starting with 1. So a1 will be 6 into 1, 6. Okay. a2, 12, 18, and so on, right? So you have difference of these 6 between two consecutive terms. So a1 will be 6. Then an plus 1 will be an plus 6. Then this one, a1 will be 3. Then you have difference of 2 everywhere. So n plus 1 will be an plus 2, right? Here it is, a1 will be n, an plus 1 will be, second is 10 square, 10 cube, and so on. Means we are multiplying the last term by 10. So 10 into an. This is your recursive definition. An is 5. So a1 is 5, a2 is 5, a3 is 5, and so on. An plus 1 will be equal to the last term. Okay? Clear? Then we written for the sum of first and positive integer. That is, sum of first positive integer will be f of 1. That is 1. And for n plus 1, it will be sum up to n plus 1. And that is coming as n plus 1 plus fn last term. That is, recursively, you can find the value of f at larger value from the smaller values. That's it. Any other doubt you have? Yes. Any doubt, anyone? No? Which chapter? Chapter 5. You want me to complete right now? Yes, Deep. What do you want me to do? Chapter 5? Okay, not in chapter 5. Up to chapter 3. You have to complete up to chapter 3 for medicine. Medicine syllabus is up to matrices. Yes, there will be 30 questions MCQ based. Okay, and obviously 30 marks. And time is 1 hour. Duration. Okay. And after medicine, there will be quiz also. Yes. Yeah. That's why today and yesterday was revision, no? And we were doing for last 2 weeks revision. डिस्क्रीट मैथ्स का तो रिवीजन कर करके थक गए होगे, है ना?
Yes, ma'am.
Anyways, ये एंड सेम में भी तो काम आएगा. Yeah. After mid sem there will be quiz. That is also syllabus. For that is also first 3 chapters. So just after mid sem they will conduct this quiz. Okay.
And what is there in quiz?
MCQ. 10 marks. 10 MCQ. Okay.
Okay, ma'am.
August chapter 1 to 3.
Ma'am, anything about college opening and end sem?
Yes, what you asked?
Anything about college reopening and end semester?
Reopening. End semester will be in March. Okay, March mid or so, around 20th March or so. I don't know. And reopening, I don't know. You will get information. Don't worry about that. Right now, you need to worry about only mid-sem and quiz. Okay. Anything else? After this class, you have one more class, I think, right? Economics.
Yes, ma'am.
Okay. सब में ऐसा ही चल रहा है क्या? रिवीजन 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 एंड रिवीजन.
No, ma'am. मैं आप में ज्यादा चल रहा है.
Okay. टाइम ज्यादा मिल गया ना की बार. मिड सेम बहुत लेट हो रहा है. अदरवाइज ऐसा होता नहीं है. We are left with 7 more minutes, 6 or 7.
मैम हम लोग डिस्क्रीट मैथमेटिक्स फर्स्ट ईयर ही पढ़ेंगे कि अगले साल भी पढ़ेंगे?
अगले साल हो सकता है. यस, इसका एडवांस वर्जन मिलेगा. वो तुम्हारे कोर्स में होगा या नहीं, आई डोंट नो. मे बी CSIT या फिर CSC में, बट होगा.
मैम हम लोग का तो CSE ही है.
तो CSC में आई थिंक IGT मतलब ग्राफ थ्योरी देते होंगे. There will be two courses, IGT, that is Introduction to Graph Theory, and Advanced Discrete Mathematics. So where we will stop, that is we will leave this up to the chapter, I think 6 POSET something. So that will start from POSET. Okay. That I'm not sure that is there in your syllabus or not. But yes, there is ADM, that is Advanced Discrete Mathematics also. क्यों अच्छा नहीं लगा डिस्क्रीट मैथ्स?
नहीं मैम, जब आप पढ़ा रहे थे तो शुरू में बाउंस हो रहा था, उसके बाद धीरे धीरे समझने लगे, बुक से पढ़े तब थोड़ा समझ में आने लगा.
मे बी थोड़ा फास्ट जा रहे थे स्टार्टिंग में.
यस मैम.
अभी तो क्लियर हो गया होगा सबको, आई थिंक.
यस मैम.
Okay, good. Okay, do well in the midsem and quiz. All the best to everyone.
थैंक यू मैम.
Should I stop? I can stop now. 5 minutes are there. Thanks all.